part 2 to demo target for C. And something that I forgot to mention in the last, in part 1, was that we know that this is going to be the minimal POS or SOP form, is because in each of these terms, not all of the variables are present. The first term, A and C, are not present, and the second term, B, is not present. And now we're going to move on to CPOS form and POS form. And that stands for canonical product of sums form. And for this, we're looking for any outputs of 0, because if any of the outputs are 0, that means, or if any of these terms have an output of 0, that means the entirety has an output of 0. And this is going to be signified with a capital M subscript of whatever binary number represents the row. So M1, M4, M5, and then Q is a function of ABC equals pi, and we're just going to write the integer numbers 1, 4, and 5. And then we can move on to canonical product of sums form. So it's going to equal Q again. And as mentioned before with my trick, whatever output we're looking for, so for CPOS we're looking for 0, that's going to be the value of the literal. So the literal equals 0, or 0 equals the literal, and 1 equals its complement. So that being said, the first one that we have is M1 right here. So the literal equals 0. So it's A ORed with B, ORed with C complement, and then we have A complement, ORed with B, ORed with C, ANDed with A complement, B, C complement. And then just like before, to find the minimal POS form, we're going to have to perform Boolean algebra. So here we have an A prime B that we can factor out. And we're going to OR that and multiply the remaining terms. So any literal ANDed with its complement just equals 0. We're going to drop everything else. And then again, we're going to be looking for common values. I see this B that we can do. And this is going to be ANDed with A and C prime multiplied by A prime. And since these are multiplied, I'm going to distribute. And any, just like this row before, this is going to cancel out and equal 0. So Q equals B ORed with A prime C. And because these are multiplied, we're just going to want to distribute those. So we have Q equals A prime ORed with B, ANDed with B and C. And this is going to be our minimal product of sums form. And again, we know this because not all variables are represented in each term.